Thanks, Calvin. Yeah, so there's a month to go. I think my advice to the project teams is just full tilt. Like I would start now, just trying to flesh everything out and getting something working. You know, it's the old Donald Knuth statement. I don't know if you guys know Donald Knuth at all. K-N-U-T-H. Knuth was uh, one of the luminaries in our field. He wrote, if you're looking for a gift that says, I'm trying to impress you, but I don't know actually who you are, you can, is it computing? It's in the title. You can buy the complete set of Knuth's Art of Computer Programming. Oh, come on, there's got to be a nicer version than that. Knuth Computing, leather maybe? No, that's not what I'm looking for. Anyway, Knuth wrote this whole series, The Art of Computer Programming. There's actually some beautiful like presentation versions of it, you know, in a nice slipcase and leather bound and so on. I think it's about $1,000. But when you get that big, oh, here we go. Is that it? Oh, well, a box set 1 to 4. How much? That's only $200. That's actually a really good bargain. When you get that fancy job after you graduate, you can buy your boss one of these in appreciation. I would say buy your professors one. We all have them. All right. Oh, I was going to say what Knuth said. Knuth said his mantra was, get it done, get it right, get it fast. So that's what I try to do is like, I just get something done, like get it out, you know, code it up, get it kind of working, you know, maybe a couple of kludges in there, but get it done. And then you circle back and start cleaning stuff up to get it right. And then if you need to, you can go back for a third pass and do a performance run and like figure out how to get it fast. Get it done, get it right, get it fast. It's a t-shirt, right? Actually, that should be our next computer science department t-shirt. That'd be awesome. Alrighty, so we're talking testing today. So, I mean, test, you know, there's some silly formal explanation for it. I mean, testing is just trying to fix any issues that have crept up in your code before we ship the thing. Like we don't want to ship a product that's buggy, right? And so we do testing, just a lot of testing. As I said last week, at, you know, Fidelity, when we were doing budgeting, a third of the budget typically was for QA and testing. So on $1 million project, that's, you know, over $250,000 set aside for test. And we would always allow, you know, especially on big projects, months of testing time. It's just really important. Like what does testing even do? You know, it's really hard to put your arms around. Like, you know, the obvious thing is let's find all the bugs. But like what is even a bug? Like sometimes a bug turns into a feature, you know? It's like, oh, every time I click on this pops up. Well, people get used to that. And if you go and fix that at some point, they're going to be annoyed because you fixed the pop-up thing that really was a bug, but they all got used to it and it was a nice feature for them. So like we're going to be testing at a really low level. Like almost every function gets tested out the wazoo. But then we have to test larger and larger chunks. You know, we test the functions, we test integration with other parts of the application, we test the application itself, we test the application against, you know, its production environment, like all these different levels. And we might test things like performance. Usually performance testing comes toward the end, unfortunately. That requirements conformance testing, that's all about companies, and a lot of companies do this. They have formal requirements tracking software that they use. So, you know, you're working on requirements that, oh, I need to update this requirement. The screen should be blue instead of red. Well, you've got to enter that into the requirements tracking system. Like we're tracking who made the change, why they made the change, who approved the change, who's doing the work on the change, how the change was tested, and so on. So that requirements conformance, that's a big part of testing, just making sure that we did the right thing. Because, you know, as I'm hoping that you realize at this point, like requirements can be really, really hard. The business doesn't have the language that we have to describe technical stuff. Like they don't know what they can't do, basically. So if we've got a requirement in the documents that we didn't meet or we met in a different way, that's going to pop out when we start doing requirements conformance testing. Oh, look at that. Look at that. Look at this fancy little thing up here. Who knew that was even a thing? Image styles. Image. Oh, that's really cool. Sorry, just got lost. It's probably a bug. You know, it's probably a bug that's, oh, we're not supposed to show that image, but now we're used to it, right? All right, so we're basically, there's a bunch of slides here. We're basically going to test small to large. The small testing is going to be on you as software engineers. We do unit testing. Unit testing is almost like functional testing. The basic idea is that you pull open the requirements, you see, oh, I need to write this function. What does the function do? What are its inputs? What are its outputs? A lot of companies will write a test at that point. You haven't even written any code yet. You write a test for that function because you wrote it, right? So you know what goes in, what comes out, what it's supposed to do. You write the test to meet the requirement, and then you run the test. I mean, if you haven't written any code, there's nothing there, so it's going to fail. And you go and fix that by writing some code and running the test again. But the unit tests tend to be based entirely on the requirements documents. And then we start moving out from there. So that's going to be us as software engineers doing that testing. Then we're going to start, you know, as the code becomes more complete, we'll start checking stuff in, like to Git. And usually, and again, we're talking large projects, usually in those projects, checking something in like that will trigger more testing. So you've got testing one layer up that is now testing stuff as it comes together, kind of integration sort of testing. We're integrating all the pieces that people have written. I'm assuming a large team, you know, more than 2 people. So everyone's writing different stuff. We have to test that stuff together. And that often is triggered by a Git check-in. You can run a script on that event of check-in. And sometimes it happens several times a day, especially if I'm in an agile shop. I'm going to be doing check-ins 2, 3, 5 times a day. And each of those check-ins is going to run the integration tests. It's called continuous integration. We just keep building up as we go, keep running tests. Some are going to fail for sure because not everything's going to be there initially. But we just keep testing and integrating. And at some point we get up to like an actual thing that we can send over to QA. And it's not really, I don't really see any QA stuff in here. They get staging here across an integration test. I don't really agree with that. Like the next step usually is a formal QA analysis. So we do all of our unit testing, we start checking stuff in, we start doing integration testing on the application. Then when it's ready, we send it over to QA, and QA is going to do a whole suite of tests on this thing. All of those tests that they're running came again from the requirements documents. Like they initially, when the project first starts, get a hold of those requirements as soon as they can and start writing tests. So that when the application shows up in QA, QA's quality assurance, when the application shows up in QA, they've got all the tests ready to go. Because normally a QA is a small group and their time is really, really valuable. Because if you think like there's one QA group in the company and I got a lot of projects running, they all need QA. It's a limited resource. And so those guys have schedules that go out a year, sometimes, you know, project schedules. Like there's no big window for them to write tests when an application shows up. It has to happen earlier. And to that point, I'm sure I'll say it again at some point in here, just because I say it a lot typically. If you miss a deadline, you're really going to screw your application up, your project, because QA is so tight in their scheduling that if you miss a deadline to go to QA, like they might not have time for, you know, a month to fit you in, because it's not like oh, QA, here's my application. They run a couple of tests. Okay, you're good. No, it's usually a 2, 3, 4 week effort for them. And if it's really understaffed, which most QA groups are, they're just not going to have time to look at your app. And that possibly means that your whole project is going to slip. And slipping is probably the worst thing you can do at a company as a software engineer, if it's your fault, especially. And I'm using this word slip. It's mean the schedule slips. The worst part is that a lot of companies plan their cost slipping. Yeah, a lot of companies plan their releases around end of quarter, especially end of fiscal year. Uh, if they're on, their fiscal year ends in September, for example, you're going to see a lot of releases in the fall, and they almost always align on that quarter boundary. It's just so dangerous because you slip a week, now you're into the next quarter, and maybe the company was depending on revenue coming in during that quarter from your project, and now you've slipped into the next quarter. Those quarterly numbers are going to look pretty bad. And Yuval says, how can QA design and test if they didn't write the app? Is there some formal spec that they're following? Yeah, it's the requirements documents. So the requirements, I mean, our requirements in here, we've just written some really simple user stories sort of things. On a real project, a big one, the requirements documents are voluminous. And it's, it's almost to the point where we should have like a requirements programming language. That'd be awesome, because the requirements are so detailed typically that, I mean, language doesn't matter really, because you can write those apps in any language based on the requirements. But like the requirements should be really, really detailed to the point where like there's no leeway, there's no room for, creativity, I guess is the word I'm looking for. So they have those documents early. Remember, requirements is one of the first things we do in the inception into elaboration phase. And then, maybe it takes 6 months to code up the application. QA's had that document for 6 months. So they're writing against the requirements documents. Yeah, but around slipping, like my advice to you guys as employees, as software engineers, anytime, and it's a fine line, but really anytime that you realize that something has gone wrong, you've got a problem, you've hit a roadblock, somebody else on the team isn't pulling their weight, like whatever it happens to be, raise a red flag early. If you wait till the end and say, oh, well, yeah, we missed that date because I didn't have time to do this or whatever. If you raise that flag at the end, that's not useful. And, anger is going to be pointed in your direction. If you raise it early, then there's time to mitigate that. There's time to figure out a fix, get you help or get somebody else help or get the equipment you need, whatever it happens to be. The earlier you raise that issue, the more smoothly things are going to go for the rest of the project. And honestly, I've been there too. It's like you feel like you're going to get blamed or people are going to look down on you. Oh, he's so stupid, he can't do this by himself. That's not the case at all. Like, honestly, nobody cares at work. Nobody cares. They just, there's a job to do. And at the end of the day, it's either done or not. So just raise that hand and say, I got a problem here. Can you help me with this? Or how are we going to solve this? And if you do that early, like if I'm your manager and you do that early enough, like I'm going to see that as a real positive. Like when I'm doing your reviews or something, like, oh yeah, Frank, like really proactive in identifying issues and bringing them to our attention. And that helps smooth out the project. Andrew says, fail early and openly. Yeah, absolutely. And the other thing is like, don't be afraid to fail. I mean, not this class, of course, but like even in life, like, failure is just part of living. And I mean, you might take a short-term hit in prestige or your confidence, but long-term, the more you fail, I think the better you do. I've failed so many things in my life, just tons of stuff I failed at. And I think in the end, like I feel pretty good about my career and my life. That I've done fine. But boy, did I fail a lot. I flunked college twice. I went to Indiana State University. I was a music major and just walked out one day because I didn't want to be a music major. It turned out after spending almost all of my life being a musician. It's like, no, I don't want to do that. So I just left. And then I had a full scholarship at Syracuse University in the engineering department, electrical engineering, full load, and flunked. Like I didn't have the, the discipline really to be in school at that point. So I failed college twice, and then ended up at State University of New York later on and got my degree, and then went on and did my graduate work. And I mean, the failure at Syracuse was a big deal because I was in the Air Force at the time, in the military, and I won a scholarship. They gave like 3 scholarships every year to enlisted people to go anywhere. I had a full scholarship to any school I wanted to go to in the United States, any school. I chose Syracuse and then threw it all away. That was a big failure. A lot of people are shaking their heads on that one. But as I said, like all those failures, like really like build, it's the old dad joke, oh, it builds character, but it does build character. If you're not failing, you're not trying hard enough, I think. Wow, where was I at? Sorry about that walk down the nostalgia lane there. Yeah, so as we move out, like the integration stuff, mainly integration is done more at the dev level, so software engineering level. I see it as just the next step up from unit testing, but then we're going to ship it over to QA. QA is going to spend a whole period of time testing the application against the requirements, generating bugs. That there's a cycle where they identify bugs, we fix them, we resubmit, they identify more bugs, and it's just a circular thing. Then at some point, QA is going to sign off on it and say, yeah, we think this is fine. There's even more testing now. Now I've got to test it in a staging environment. So it's going to move from a QA environment into stage. Staging is about duplicating the production environment as closely as I can. Same applications, same hardware, same networking configurations, and so on. And usually the staging environment is slightly smaller than production. So, if I'm scaling a bunch of stuff in prod, I probably won't do it in QA. I'll maybe just have one machine, but it's going to look as close as possible to that to that production environment, same databases and so on. So that staging test is more about like, all right, this is the kind of the final test before we push it to production. I want to make sure that it works in the environment that it's going to run in. And as I said last week, an advantage of having those staging environments is that if production fails for some reason, hey, it's a miracle. I've got a set of machines that are close to production quality that I can swap over to and use those while I'm mitigating the issue in the production machines. A lot of places don't do that. Blackboard comes to mind. We always get these notes from administration. It's like, oh, Blackboard's going to be down for 2 days while we do an upgrade of some sort. Every time I see that, I think like, don't we have 2? Like, why do we just have 1 machine running Blackboard? Like, have 2, right? So you bring one down, upgrade it while the other one's running, and then you swap them. So weird. I don't understand that. I guess we don't have enough money for that sort of thing. Like critical infrastructure. No money for that. So once we get out of stage, that's going to be, those are more high-level tests in stage because you've been through the ringer in QA, doing like the real QA stuff and going through that cycle of fixing bugs. Once I get to the stage environment, I don't expect to see a lot of issues. In fact, I don't expect to see any issues really at that point because we should have a really good understanding of the app and its shape and so on. I'm also going to do a validation test at that point, or an acceptance test. The acceptance test is done by the sponsor essentially. If I'm building this for a third party, it's going to be the third party who comes in and runs their own set of tests to say, yep, that's what we were looking for. Or if it's an internal project, it's going to be the business sponsors. Like they've got to come in with some set of tests and run the application in the stage environment and sign off on that. So that final acceptance test is whoever's paying for this thing is going to say, yeah, it looks pretty good, and sign off, and now I can push to production. But even then, like, now you've got an app in stage that's been signed off 2 or 3 times, right? Once we push to production, we got to test it again. because now it's in a new environment. It's got new keys, new IP addresses, new hardware. It's in a different place, and we need to test it again. But at that level, now I'm just doing smoke tests. Probably a smoke test, is just you put it through its paces really quickly at a high level and make sure that most stuff works. So it's kind of the cycle, and then we start all over again. Yeah, as we're in production, we're going to generate bugs, right? Users are going to generate bugs. We're going to generate bugs as we see the thing run. Maybe the system is logging stuff that we have to take a look at. And then we just start all over again. The next project, day 2, is going to be, now we got a bunch of bugs. We need to upgrade the application in some way. And a lot of your work, when you guys get like your first real software engineering job, a lot of that first year is just fixing bugs. It's a great way to learn the code base because you're in looking at other people's code. You can learn like how this company builds applications, what code looks like, what libraries you're using, what styles are there, and so on. It's a great way to get your feet wet. I did it several times. When I would go from company to company, first thing you do, spend time even at a high level as a consultant. First thing you do, start killing some bugs. All right. So here, this is the big word right here, quantifiable. All those requirements documents that we have, I said it a couple of times early on that a good requirement is measurable. That is so true when we get into the testing environment. If I've got a requirement that doesn't have a measurement against it, like how am I going to test it? Is it like it makes me feel good when I run the app? But it's like, how am I going to measure that? Right? It's going to be, I put a 4 in and I get a 7 out, or under load the performance curve looks like this. Like quantifiable stuff that we can test. Those are the real requirements. And I think that I know some companies will put caveats in the requirements around testing itself, like, oh, be sure to test this, or, we're not so concerned about that. No company I ever worked at did that, but I have heard it anecdotally in the field that some folks do that. All right, let's talk about those bug lists, because we're going to be generating bugs. The bug list can get quite large. I remember being in bug meetings. Basically what happens is you'll go through the QA cycle. The app moves into QA. In about a week after they've been running some tests, you'll get your first QA report. It'll be a really long list of problems that they found. That's the bug list. Like really long. Like I've seen bug lists, especially early on, in the hundreds. What you have to do then is, let's say I've got this list of 100 bugs that QA came up with. We have to decide which ones you're going to work on. Like this, it's not possible to do them all at once, clearly. And so we just prioritize them. That's what this triage word means. It's where I learned the word triage was on MASH. That's when the injured people come in from the field in war, and they're laying all over the ground, and some people's arms are missing, and some people have a toothache or something, and the doctors just walk through and say, prep him for surgery, give him some aspirin, he's gone. Like that's triage. You're prioritizing the work based on the need. That's what you're doing in these triage meetings too. You're sitting around going through the bug list and just marking them high, medium, low, or showstoppers. Those two, the two top categories are showstoppers and high levels of severity. Those are the ones you're going to work on first. If one of the bugs is, oh, the word should be blue and it's green, like, I mean, unless that's critical, I'm probably not going to touch that one for a while. But showstoppers for sure. Showstopper means that you cannot ship until that bug is fixed. Even high level bugs, you probably wouldn't ship that product until those were fixed as well. But like, these meetings are wild. I mean, these days I'm pretty laid back, but I remember being in bug triage meetings where, I was the guy in charge of stuff and pounding my fist on the desk and yelling, "We cannot ship this until this is fixed. Go right now, leave and go fix this bug," over just silly stuff too. It was like stuff that just didn't even matter. But these issues, these meetings get really contentious, I guess is the gist. And you've got just so many people in there. You've got the development team is in there, or at least the development lead. You've got the project manager, the product manager, QA is going to be in there. Um, Maybe the dev manager. I mentioned the dev manager already. There's just a lot of folks in that meeting. The business is going to be there, and everyone's got their own opinions. And so it's really important to come to consensus on what's going to be done next. And then you get to go through it again in a week. So you go back and work on those, high severity and showstopper bugs. And then you do it all over again. You get a new list, and hopefully the list is shorter. So that's triaging. And by the way, the progress on this stuff is really, really closely tracked in most companies. You're going to end up with charts like this. Your manager is going to keep data like this on you. It's like, all right, how many bugs have we created? That's the red line. How many bugs have we fixed? That's the blue line. And what's the delta, or the difference? If your chart looks not like this, if you're creating more bugs than you're fixing, and over time the backlog keeps going up and up, that's a real problem. And if I'm your manager, we're gonna have a talk about that in your next performance review. And if it happens more than once on more than one project, I'll probably be looking to replace you. Like why would I keep you on my team if you're creating more work than you're actually doing? That is just costing me money and time, right? And maybe there's so many bugs that we're going to slip across a quarter, and then we're really screwed. Like no, there's a lot of people who want your job. If you can't manage to fix bugs, you're of little use, really. We'll find somebody who can fix them. So, but just be aware that you may not see these charts. Like these are sort of management sorts of things, but for sure they're going to keep this on you. And how do they track it? Like you're assigned bugs to work on, and actually when bugs come up, they're assigned to like, oh, bug here. Oh, this is Donham's code. So they know who created the bug, and then they know who fixed them, because as we check them in, we're marking it off in the bug tracking system. I worked on this, resolved, done, logged. So all those numbers are there. Just be careful. All right, so that's kind of bug tracking, like triaging bugs and so on, and kind of the whole QA process, the full cycle. There's other stuff that goes on too. So we've got this V&V notion, V&V, and I guarantee this will be on a quiz at some point because it's an easy one. Verification and validation. Verification means that is the code correct? So this is straight up language-based code. So you've got a dangling pointer here. You've got an array, but the array's sized improperly, that kind of stuff. So that's the verification. Is the code correct? And then the validation, is it a valid application to begin with? Validation means going back to the requirements and mapping each requirement onto a function of the code. That's the validation piece, or we're building the right product. V&V, some companies have a V&V group, and that's all they do. V&V at places that I've worked has mainly been actually pretty informal at the places I've been. V&V mainly was, if it wasn't a security review, it was sitting around with senior developers, maybe some management, usually not management, because once you get into management, you start losing your development skills. But certain, senior developers, somebody from QA, you literally go through the code line by line, and you just sit in a room. We usually print them all out. You sit in a room and go through it line by line. Why is this pointer here? What's it pointing to? Why is it not null? All those questions. Some of those are bugs, but some of them are just style. And verification really is about conformance. You want the code to conform with your local styles, your local process. Just make sure that the code, actually make sure the code is maintainable is what the verification step is for, I think. And validation, that's more about for companies who keep formal requirements tracking. If they're using rational rows or something to track requirements, each of those requirements will be mapped to a piece of the code, to a function in the code. And that's usually a quick step. Like we just have to go through and make sure all the requirements have corresponding code against them. And actually the reverse, which is harder to find, but is there any code that was written, any functionality that didn't have a requirement against it? That's a problem too, because that means that the application isn't what we expected. Somebody added something to it without there being a requirement. Like, oh shit, now what do we do? Like, we got to go through everything now and see what else they put in, or just, put them up against the wall and shake them until they tell us, I guess. We'd never do that in business. But validation usually is an easier step, because if you're doing validation, requirements validation, you probably already have a requirements tracking system, and it's really just reporting at that point. But verification, that's going to be on us. Like we basically have to defend everything that we did in the code. Who tests this stuff? No, I mean, we do unit testing for sure. Yeah, as we write code, we're writing tests and running those tests at a really low level. We might work on some of the integration testing as well. The problem with that is it's the old joke about the guy who goes into the doctor and says, "Doc, it hurts when I do this." And the doctor says, "Don't do that." Well, it's the same thing with code. Like I have code right now that I'm currently working on that's like this. Oh shoot, I know. Never put a negative value in this field because it crashes on a segfault or something. And so over time, I just stopped doing that. It's like, oh, I know it's going to kill it if I put a negative value in. And so I just don't put a negative value in because I have work to do, right? So we know what the code does and what it doesn't do and where its touchy points are. QA doesn't. And that's why we use QA. We need an independent tester who like doesn't care. Like it's not their code. They don't care what happens to it. And so they'll just do, sometimes you called it monkey testing, because it was just, oh, I designed this very carefully and I wrote this code. So the sequence is 1, 2, 3, 4. And then QA is like, 3, 2, 4, 1, 1, 4, 3, 2. Like you just try everything, all different combinations of stuff, trying to break the thing. Which is great. I mean, that's their role. And I'll say this also about QA. Software engineers, for some reason, have this, I don't know, attitude about QA. It's like, oh, they couldn't make it as an engineer, and so they're in QA instead. And thinking about the places I've been, usually the QA team was made up of folks who were not formally trained, and like they didn't have a bachelor's degree in computer science from BU. Maybe they had an associate's degree, or they learned some coding in high school or something. They tended to be not formally educated. I mean, some were, of course, but it's basically an entry-level position at a lot of companies. What we did see, though, and this is true just about everywhere, there's always a couple of folks in QA who really have an aptitude for engineering. And because they see so much code and work on it, and you'll find these people, and when you find one, like latch onto them because they're gold. As a developer, like you need to develop friendships with those people. Like there's always a couple of folks who really have the aptitude, and they use QA as a stepping stone. They'll go from QA into software engineering. Actually, I helped a guy at CCME do just that. Like he was really sharp. He dropped out of school after his first year or something and went to work, but he had the aptitude. He really had a good skill set, and we helped him come up to speed, gave him small projects, and as he did those successfully, we moved him up into software engineering. So there's a weird vibe sometimes between software engineers and QA. And also because of this, right? So we've got these people who are taking our baby and like poking it with hot sticks. Like, dude, don't touch that way. But that's their job. And it's almost an antagonistic kind of relationship. They're telling us all the stuff we did wrong. People hate to hear that. I hate to hear that. But I mean, at the end of the day, my advice on that is you're going to have those feelings. I had those feelings. I used to get really angry at QA when they tell me all this stuff I screwed up, especially in front of other people. Like, oh yeah, these are all Donham's bugs, you know, and they throw them up on the board. At the end of the day, like, it just doesn't matter. It's not your code. If you're working at a company coding as a software engineer, it's not your code. You're writing code for money, and you get to keep the money. They get to keep the code. It's not your baby. You know, I know there's a sense of pride of ownership sort of thing as we're working on projects, which is great. Like, ride that as long as you can, but really it's not yours. It's, you know, it's you're doing work for somebody else. They own this stuff. If QA wants to tear it apart, like, what do you care? You're still getting paid, right? Maybe you only hit that attitude after you've been there a few years. It's actually, you know, to be perfectly honest with you guys, like, that's a lot of the reason I left software engineering. That's what I was. I was a software engineer for a long time. And then I sort of moved into consulting and, you know, did the other stuff. But at some point you just realize, like, I'm just doing this for money, and I enjoy coding for sure, but it's not my product. It's not my process. You know, other people are just telling me what to do all the time. They expect me to do more work than they're paying me for. Like all these companies that expect you to work 50, 60, 70 hours a week, you're getting paid for 40, you know? It's like, this is not right. And at some point you realize it's just not worth it anymore. And I hit that point, fortunately, fairly recently, fairly early in my career, and started going in other directions that made me happier. But when things feel bad at work and you feel like everyone's just coming down on you, just remember that that's not life. That's just work. Just work. You can say the same thing about school, but school is important. All right, so we're going to find an independent tester. Testing strategies, we're going small to large, unit testing out to final acceptance testing. I won't say too much more about that because we spoke about it a lot in that first slide. And then I did mention smoke testing. Excuse me. Smoke testing is just a really high level, turn it on and see if it catches fire sort of thing. Actually, there used to be, is it an opcode? That was an error. Wow, I'm trying to remember what that was. This way back in the recesses of my memory. There used to be an error message, printer on fire. It was built into, was it Solaris? It might have been built into Solaris. You get an interrupt and the error would be printer on fire. It was a joke that somebody put into the operating system. But smoke testing is really high level stuff. Usually I'm doing a smoke test if I'm moving the app into a new environment, like into QA or stage or prod or something. I'm going to have a set of really high level tests just to show major functionality works. Turn it on, run those tests, you know, maybe takes an hour and you're done. Maybe I'll do this for daily builds too. If I'm doing continuous integration, doing basically a build every time I do an upload to the repository. But yeah, daily builds, I guess, but daily builds we're usually writing unit tests on. But smoke testing is for large stuff. It comes from the old adage, you know, from engineering that electronics run on smoke, and you can prove it by taking a hammer and whacking your computer with it. And what you'll see is there'll be a noise and all the smoke will come out and it stops working. So clearly electronics are run on smoke. If you find a showstopper error when you're doing a smoke test, you need to fire the QA group. You should never, ever, ever find a showstopper error in a smoke test, because usually when you're smoke testing, that's the end of the road and you're ready to sign off on something. Oh, thanks, Eva. Oh, sweet, man. Let's go look at that one. Let's see how my memory is. LPs are on fire. Unix machines. Yeah, which one was it? Oh, it was Linux. No kidding. No kidding. Oh, that's so funny. In 92. Wow. Yes, it's still there. That's funny. Oh, yeah, and you know why? I just noticed it in there. There was a halt and catch fire instruction in the, there was an opcode for the CPU, this one. This one. And which machine was that? The 6800, the Motorola. Ah, nice. 09D and 0DD. So funny. Halt and catch fire. All right. I thought it came from IBM though. Halt and catch fire, case of etymology. Oh yeah, the IBM 360. So good. All right. So unit testing, we have some issues around unit testing. Here's the stuff we want to test. Like I just want to test everything. I want to make sure that my testing covers as much of the code as possible. It's not always possible to test every single line of code, but we can run things like a profiler, for example. If you turn on a profiler and run the application against it, that profiler, if your code has been instrumented properly, it'll tell you how much of the code actually was used during your testing. And if you're doing like high level stuff, like really, work on the application, you'll see that, oh, there's a whole branch of code over here. Like there's an if statement maybe that was just never reached. And you can go and look at that. Or you'll see things like, this section of code, maybe it's like a thread handler or something. You spent 47% of the application processing time in a loop in this branch of that code. Well, that could be a problem too. That's a hotspot. We used to do that all the time on performance tests. When we get called into a client to do performance testing, we'd instrument out their code, we'd run a profiler against it, and what we would get would be a report back, and it would literally color code stuff. Like this section of code would be in red because I'm spending so much time in there. And it would just, the worst one, we'd go in and say, oh, what's going on in here? And maybe it was, there was a loop with an incorrect bounds, or there was a memory issue, or something. Like we'd see there was a real bug, or we'd realize, holy crow, and this goes back to the premature optimization question early on, right? We'd realize, oh shoot, like who knew that we were going to spend so much time in this tight little loop? Like, let's optimize this loop now. Maybe it shouldn't be a loop. Maybe we should unwind it into a series of linear steps. But hotspot reporting like that with a performance coverage analyzer can tell us where the problems are in the code as it's running. But these are all things we have to test. So, the interface itself, if I'm writing a module or a library or something, or even a function, it's got goes intos and goes outas, right? Stuff that comes into it, stuff that goes out of it. I've got to test all of those, and especially boundary conditions. Boundary conditions are so critical. We essentially, off by zero is such a common error in computer science. It still happens to me. Happened to me a couple of weeks ago. I was teaching in 210. I was like, oh, right. And we start at zero. Off by zero is so common that we have special tests for it. Essentially, anytime you've got something with bounds, let's say it's an array, you're going to test the middle of the array. You're going to test each end of the array. Let's say this, the array goes from 0 to 9. I'm going to test the 0 case. I'm going to test the 9 case. I'm going to test the -1 case. I'm going to test the 10 case. Those edge conditions are almost always where the problems occur. Like we're pretty good at writing code for the average case. We hit those bounds, that's when problems start to come up. And so those boundary condition tests are just really, really important. If you write no other test, as long as you're testing boundaries like that, you'll probably get by. The other problem that we have, though, is that like a lot of times, some of this stuff just isn't there. And we'll get to like the definitions of these things in a sec. Like I want to do testing, but the application isn't done. Like, how do I handle that? Like I want to do all these boundaries and interface and so on. But these things down here, these where they say stub, like those just aren't written yet. And I still have to test that. I mean, the short answer is these stubs down here will write code that mimics what should be there. So let's say it's a function that adds two numbers together. I haven't written the function yet, but what I can do is write the function definition and just have it return some value instead of actually doing the work. Just immediately return 6 or whatever, and that way I can test the stuff that's above it. It's not done, but at least the interface between it and the rest of the code is complete. And so I can run those tests and then fill that stub in later as I go. Some companies do this. It's actually not a bad approach. I alluded to it earlier. This test-driven development process, you essentially write the test first, and then you run it before you've written any code. It's going to fail because you haven't written any code. So the idea is you run the test, and then you fix the first problem that the test found. Well, the first problem of this one is code not found. So I go write some code and run it again. It's going to come up with another set of problems. I pick the first one and fix that one and then run it again. Again, I'll have some problems, pick the first one and fix it and so on. So you just keep doing this iterative process over and over. That's what iterative means, Don. At the end of the day, though, what happens with TDD, and this is why companies use it, if you start with the specification document, the requirements, and you write the test based on the requirement, and then you run that test and it's going to fail, and then you start writing code, because you're only fixing one thing at a time, you're converging on the requirement. I won't say most, a lot of companies write the code first, and then they run kind of independent tests against it and see what went wrong. If I do TDD instead and write the test first, the code that I get at the end is exactly the code that was necessary to satisfy the requirement, because the test was written against the requirement. So it's just enough code to satisfy the requirement and nothing else. There's no more in there. If I do it the other way and write all the code first and then run the test against it, there could be a lot of crufty code in there that, like, I just wrote a bunch of code, right? You know how we write code. These, brain fart it all out into your keyboard and then kind of clean it up a little bit. There might be stuff in there that just wasn't required, wasn't necessary, might cause issues down the road. It certainly is going to be bloated code because it's not necessary, that code bit. So TDD has a tendency to really create pure applications that just fit the requirements, and that's all they do. I'm a fan of it. I like the process. I'm just too old now to have the patience for it. If I see a list of 5 bugs, I want to go fix all of them. And the process, you just fix the top one each time. Patience is certainly a virtue. But what are we going to test? All these things, whether we're doing TDD or not, or what's QA doing? How are they writing tests and so on? So we're testing as many paths of execution as we can find. And some of those are going to be artificial tests where we have to inject errors, because a lot of the code we write is going to be around error handling, more than half probably. We need to simulate those errors. So we have to have some way to inject those errors into the system. And QA can help us with that too. The goal is to see 100% code coverage. The reality is, if I see a number in the 90s, even 90 itself, I'm pretty happy about that. It's just really hard to write tests to test every single line of code. And so really this is just a good enough kind of metric. But certainly test everything, all the normal inputs and outputs, and then all of those boundary cases. Those are the non-normal things. We just have to test all of those edge cases and so on. Here's the t-shirt. To try ordering a lizard next time I'm in a bar. Frameworks for this sort of thing. And by the way, this what should be tested and that stuff, that applies to all of the testing methodologies. TDD especially, though, because we're writing this test up front, and we try to have the test be as complete as possible. There's a whole bunch of tools to help us with these. I don't know if you guys have seen any of these unit tests on Python, or if you're in Java, JUnit is really, really popular. On the JavaScript side, I teach Mocha and Chai in my CS412 course. We do some testing both at the functional level, and we mock up web servers. So we essentially create stub servers that we're hitting. We actually get pretty good code coverage in those. Sinon is another testing framework for JavaScript. Boost for C++, and so on. And all of them have assertions. Do I talk about assertions in here? Yeah, I do. Here's an example of, this is a Mocha test for JavaScript. These are actually really easy to write, and they're very like conversationally driven. So like, here's the test, it's the tags test, and tags should parse the long form tags. Well, what is the long form tag? These are them right here, dash dash depth equals 4, instead of just dash D would be a short form tag. So there's my long form tags. I go test them and expect the results to have a property called depth. Expect the results to have a property called hello, and that's the value. So these sorts of input and output kinds of tests, they're simple to write. And if our requirements are full enough, like, we'll catch all of these edge conditions as well. I can always do assertions. This would be this is like C or C++. An assertion is just a test for some value. And if the test fails, the program crashes. It'll halt the program is a nice way of saying it crashes. It crashes with a report. It actually prints out a report and then crashes. So here I've got a reference to a pointer, it looks like, and I want to make sure that that pointer isn't null when I try to actually use it, because if it is null, the program's going to crash anyway. And so if this thing is not null, then I have to catch that condition. It's not something I want to do in production. I mean, if you can imagine assertions in production, if my code is littered with them, like, who knows what's going to go wrong, right? And when I do trip an assertion, the program's going to halt. It's probably not what I want to do in production. And so we're going to put if statements around it. So if I'm in the debug mode, then we'll run this assertion. And if I'm not in debug mode, no. If I'm in production mode, we'll just skip it. All right, let's talk about mocks. That was this picture. It was this picture where I've got these stubs down here. Mocks and stubs are all about, these are all about testing code that's not complete. And this is similar to that addition function that just returns a 6 or something. Who knows what the data really should be, but it's just returning some canned value. At a functional level, I would call that a stub. If it's something larger, like maybe I'm using Postman, for example, not yet. Postman has this idea of new, I can do a mock server. I'm not logged in, but I can mock up an entire server. And essentially what that means is I give it a list. When the server sees this input, return this output, but it's just that, it's just a list. There's no actual guts to the server. But I can mock it up in something like Postman or other tools, or just write my own mocks. And it allows us to test against large systems that aren't there. The place where we almost always used reflectors was a database, almost always in development, in construction, if you're using the RUP methodology. But when we're doing dev, usually the databases just aren't ready. We might have some data, but it's probably not being refreshed, and maybe it's just a subset of what we really need. Well, I need to test my app against that database, and so I'll create a reflector for it. I'll just have a bunch of canned responses, and I'll probably get those canned responses from my business analyst. Maybe it was on another slide, but I'll put it here too. Data from the business analyst. So the business analysts, the BA guys, they're the ones I mentioned a week or so ago who have a foot in both places. Like, they understand the business domain. They also understand the technical side. They know what the data should look like, and they can work with the business to generate data that we can use for testing. Yuval says, where's property-based testing categories. Unit tests seem fragile. I can't remember. Unit test bounds in the middle. I might miss something in between. I guess that assumes that I can generate that though, right, Yuval? I mean, there's some situations where like I just can't predict what all the inputs are going to look like. I should add that though, because a lot of folks are doing PBT these days. Just make a note to add that. And you know, Yuval and everyone really, a lot of this stuff is it's just stuff we've always done as developers. Like clearly we're going to test our code, and every company calls it something different, like stubs, mocks, reflectors. Like some companies will call it a mock, some will call it a reflector. It's really the same thing at the end of the day. Oh, you did some for this project. Oh, sweet, sweet. I'll keep an eye out for those. See, Yuval, when I see something like that, if I were a hiring manager, and Yuval, if I knew you wrote some PBT tests for your class project, I'd just hire you on the spot. Like that's somebody who's like looking forward, right? Yuval, is that something you have done at like internships or some other job? He's typing. Oh, 320. No kidding. Oh, nice, nice. Oh my God, we do teach you guys stuff. That's awesome. I always wonder if you're actually learning anything here. It's good. There's so much theory, you know. It's like all this theory stuff. Like, where's the practical stuff? All right. Let me just mention BDD. BDD. A lot of places make a distinction between TDD and BDD. Like, I kind of see them blending together. Maybe it's just me. The idea of BDD is more, I guess it's more high level functional sorts of stuff or more high level requirements sort of stuff, not functional really. And like this, as a logged in user, I want to edit my profile page. That's the test. It's not that I'm testing the individual functions behind that. I'm not doing coverage or anything on it. What I'm really doing is it's almost like the business process view of testing. This is what they're supposed to be able to do with this functionality. Can they do it? Can they edit their profile page when they're logged in? I think that's pretty useful. I like when I look at BDD stuff, I tend to see that as more smoke test level. Like these are really high level. Like, yeah, you can edit the profile page. Great. Like what's happening underneath? You know, are data structures being set up properly? Are we losing data? Like all these things that keep you up at night. You're probably not going to see those in a BDD style test where they're just going through the process of editing their page. I'm going to see some gross errors for sure. I think I would combine them. Like if it was my project, you know, I was the project manager or product manager, I'd probably combine these things. So the BDD stuff would be early on. That would be kind of my smoke level gating sort of test. Like, oh, we're working on the login system and the user system. And once this, you know, as a logged in user, I can edit my profile page. Once we pass that test, now I can move on to do something else. And in the meantime, I'm writing TDD sorts of things against all of these pieces. So it's a combination sort of thing. That's TDD. Yeah, as I said, it's usually a mix that we use. There's a couple of different ways we can approach testing. We can start top down. So top down, I'm talking like the architecture of the application. So up here, these things are going to be very high level. That's going to be basically, I can log in and edit my profile page, and all the stuff underneath that is going to be stubbed out. And then as we test and fix and keep writing, these things that are stubs, these green things, they're going to be replaced with actual code. The test doesn't change. It's just that now I've got real code I'm testing instead of a stub. So that's kind of top down. I start with the high level stuff and then start filling things in below that as I need them. That's actually how I tend to write code. I write code in a way that I start with the high level stuff that I need to do. And then like the details fill in as I realize what those details should be. And that's probably because I'm typically writing my code without a spec. Like usually when I'm coding these days, I'm just solving some problem set that I've given to students. I want to make sure I can do it too. So I'm starting out with the high level requirement that the students have, and then filling in the details as I go. Like you can do bottom up. I haven't actually seen a lot of folks do bottom up. Almost everywhere I've been, it's been top down. Bottom up is, I guess if I had a really, really large team, I might assign some of them the really low level stuff. And then the stuff on top is stubbed out. So all these things down here, this is the, oh, that's the connector code to the database, or the thread pool we're going to use, like all the really nitty gritty stuff. And then as that completes, I can start to integrate that and test it and then move up to the next level. Now I've got a database pool and I've got a way to manage threads and so on. Now I can start writing code against it. I guess I've done that too, especially around databases. If I know I'm going to need a database for the app, the very first thing I do is write the database code, because everything's going to need it. And like, why not get that out of the way? And at that point, there's nothing above it really. I'm just working on that little piece of, small functionality. Actually, I just finished saying, oh, I never do bottoms up. I always do top down. I'm just thinking about my coding over the past few days. It's actually been bottom up stuff. So there's a problem set in 2.10 that we're working on. Actually, I'm working on to release in the next day. It involves doing conversions of infix expressions to postfix expressions, so they're going to be evaluated by an RPN calculator. But for that, it's like, oh, I know I'm going to need this kind of a stack, and I need this sort of a node to put on the stack, and so on. I wrote those first, so those were down here. And then once I had those, now I can start applying an algorithm because I have a stack now and I can use it. So I guess I did bottom up on that one. I mean, the reality is it's usually this. Some stuff we do on the bottom, some stuff we do on the top, things are stubbed out in between, and then things converge like the Intercontinental Railroad. And if you're lucky, they don't miss like they did in the Intercontinental Railroad. Well, they were close, weren't they? Weren't they within a foot or two of each other? When the Intercontinental Railroad was built from both coasts, they came toward each other, toward the middle of the country. And at the end, they had to connect the two sides together. And I think they were like within a foot. That's pretty good. Why would you even do that though? Like, if I was building the Intercontinental Railway and I knew there's going to be like a big ceremony at the end to connect the two pieces, wouldn't I figure out pretty early on, like a mile away, right? It's like, oh yeah, looks like we're just a little bit, let's just scooch this over just to the left a little bit, so that when I got to the end, they would meet perfectly, like the big celebration, right? Why did they wait till the end to figure out that they were a foot off? I don't know. Maybe that's just my version of history. All right, so that's Sanders testing. Another kind of test we're going to do is regression testing. Regression testing is testing what's already there. Let's say I'm doing an update sweep, upgrading the software. Well, I had a whole bunch of tests before, that I wrote for this project. And now let's say it's a year later, we're doing an upgrade, adding the feature or two, it's a new release for us. When I'm done with that release, I can't just test the code, the new stuff that we just wrote. I mean, of course I'm going to do that. I'll have unit tests and integration all the way up for the piece that we did. I also have to do a regression test. Regression just means that, did I break anything that actually existed before? So I'll run all the old tests to make sure that they still work, that I didn't screw something up when I added the new things. And if possible, I'll do it with everything. So I'll have the databases up, I'll have authentication running, like everything running, almost like, like an acceptance test at the end. But I have to run the regression suite against it. A good shop will run regression tests often. Basically, every time you check in new functionality, you'll do regressions to make sure that one piece didn't break something. Actually, that's good advice. I'll give you that advice right now. When you're doing bugs, and actually when you're working on any of this stuff, do one thing, then test. Don't do two things. The problem, and I do this too, everyone does this, You've got a bad bug, right? It's like, oh man, what is going on here? It's one of those things where you just, it's 2 in the morning and you still haven't fixed the stupid thing, and you're spinning, right? And you've tried 9 or 10 different things, and then finally it's like, oh, thank God, finally it works. Well, which of those 9 or 10 things that you did actually fixed the problem? Don't know. Who knows, right? Could have been any of them. It's really important to change one thing and then test. And if that doesn't work, back it out and then try something else, or try that thing in a combination with another thing and then test again. If you test one thing at a time, each time, you're guaranteed to know what it was that you changed that affected the fix. Unless it was some weird combination of stuff you did. But at least if you've been testing every single time, you'll at least know, like, oh yeah, it must have been that and this. Adam says, I always try to think of it as a controlled experiment. That's exactly it. But we panic, right? Everyone panics in development. You start slapping code down, hoping it'll work. The worst part for me is, especially like not so much this class because we're not doing a lot of coding, like 412 when it's just all code. Like I'll be working on something for class, right? That I'm going to demo maybe. Oh, man, it's just not working. Holy crow. I was like, try this, try that. Yeah, hey, now it works. And I'll stop at that point because usually it's late and I got a demo it the next day. And so I'll walk into class and show them the code, and it's just a mess. Like, oh, and the students will nail you too. Like, why did you do that? What's this code do? And you're like, oh, well, this does this, and you have to do this because of this. And no, you got me. I just threw a bunch of code against the wall and some of it stuck. Andrew says, yeah, commits should be small. That's another habit. Commit early and often. I was working on code yesterday and probably did 20 commits. Every time I change something, do a commit. Now we can back stuff out if I need to. All right, how about tools? Testing tools, what do we got, 3 or 4 minutes here? Oh, perfect. There's tons of tools we can use. There's commercial tools, there's open source tools. Sometimes all we need is log files, so I can go and grab logs. This is a log from a web server from 2015. But these are all like these things, these gets, oops, like this bit. That get, that's an actual HTTP request from some client. I can just copy that and replay it against my web server. So I can test my web server by using actual logs from previous runs. Maybe I'm going to use a tool like LoadRunner. LoadRunner allows me to simulate users so that I can sort of bring up the application, start recording in LoadRunner, and go through a sequence of maybe logging in and changing my profile, and then stop the recording. And then I can tell LoadRunner, hey, I want to simulate 50 users all doing this and vary them in this way over this period of time. And LoadRunner will generate fake users for me doing that sequence. I do it mainly for load testing. It's called LoadRunner, mainly for load testing. So I can ramp up load and watch the performance curves as the load increases, or see if there's any issues with like data that's being corrupted by some other user. It'll show that as well. Selenium's really, really popular. If you want to learn a testing tool, I would learn Selenium. It's a pretty robust suite and it's open source. End-to-end stuff. End-to-end is so important. I've written a couple of papers on this. Just not just testing the app or testing, doing like small unit tests, but we talked about this on Thursday, testing end to end, testing from, the customer placing an order to a box showing up on a truck and driving off the delivery dock, like that whole end to end business process. How are we going to know how our application fits into that and what it breaks if we don't test the entire process with our application installed? And then finally, everyone forgets content. Content is the last thing we test. And usually content bugs come out from users like, hey, dope, you spelled this wrong. Other stuff though, these are all just part of all of the testing levels that we just looked at. Performance is kind of a special test regime that's a skill set that not every QA person has. Usually you'll have somebody in the group that does performance, or like, my consulting firm, that was a big part of our business. Companies just don't have that expertise. They call us in to do performance testing for them. All right, bottom line, test everything, test it often, test every level. Most of your work, unfortunately, on the job is going to be writing or running tests or fixing bugs. That's the nature of the game. That's our jobs. All right, guys, I've got 30 seconds left. That is it. I'm gonna pack it up and head over to the GSU. I'll see you all, and I hope to see you all on Thursday. I'll try to let you know like Wednesday night if I'm not feeling well, although it might be the morning before I know. That's it. I'll see you all later. Thanks for coming, guys. Been fun as usual.
Thank you, Professor.
See ya.